The periodic table. To learn more about objects, scientists often compare and sort them in various ways. Botanists sort plants on the basis of their leaves, flowers, roots, and stems. This helps them learn about plants. Geologists sort rocks and minerals based upon properties such as composition, density, and place of origin. When objects are arranged in different ways, scientists often discover patterns they might not otherwise see. Robert Boyle was an Irish chemist. He is known for his experiments with gases. He was the first person to separate and identify elements. He studied air. He found that the element oxygen was the only part of the air that was necessary for breathing and supporting life. His work founded the study of chemistry as a separate science. His clear identification of elements made it possible for the elements to be compared and sorted. Since Robert Boyle's time, chemists have organized the natural elements of our world in different ways. An early organization of the elements was completed in 1787. Chemists ordered the elements in a line from the lightest to the heaviest. The line was not long because at that time scientists had isolated and described only 33 elements. Lavoisier's Table of the Elements. Super scientists. Joseph Priestley. Joseph Priestley was a British scientist who had no formal science training. That didn't stop him from making several important contributions to the field of chemistry. In 1774, Priestley discovered oxygen. Although Carl W. Chalet had actually made the discovery 2 years earlier, Priestley was the first to publish his information. He eventually identified most of the common gases. New and improved arrangements. In 1817, a German chemist named Johann Dobereiner organized the elements by their similarities. He placed all the elements that were gases in one group. In another group, he placed all the elements that were metals. In 1864, English chemist John Newlands found that every eighth element was similar. He described this regularity as a period. He prepared a chart in which the elements were set in rows. Each row had 8 elements. He said his chart was a periodic chart, or one that showed regularity from one section to another. He named his chart the Law of Octaves. Mendeleev's periodic table. As time went on, scientists discovered more elements. In 1869, a Russian chemist named Dmitry Mendeleev put together a chart showing the 63 known elements. Mendeleev's chart organized the elements by both increasing weight and similar properties. Mendeleev observed that for his chart to make sense, he had to leave spaces between some of the elements. He believed the spaces indicated that more elements were yet to be found. The table sped the discovery of these elements by showing other scientists what properties the missing elements would have. Mendeleev's chart is called the periodic table of the elements. It is the most famous of all the ways elements have been organized. It is named the periodic table after Newland's concept of a period. The elements show a repeating sequence of properties throughout the table. Elements with similar properties are positioned close to each other on the chart. In addition, Mendeleev ordered the elements by their increasing weight. Today, their order is not based upon weight. They are ordered by atomic number. Hydrogen is 1, helium is 2, and so on. Atomic numbers tell something about the number of parts that make up an atom. Today, the table contains all the known elements. You can see an updated version of Mendeleev's table on the wall of most high school science laboratories. Mendeleev's periodic table of 1871. Super scientist Dmitry Mendeleev. As the youngest of 14 children growing up in Siberia, Russian chemist Dmitry Mendeleev might have been overlooked. However, his mother recognized his gift for science. When her son was 15, she took him to St. Petersburg so that he could study at the Faculty of Physics and Mathematics. In 1869, Mendeleev reorganized the known elements to make a new chart called the periodic table of the elements. In addition to grouping the elements for study, the periodic table also allowed Mendeleev to predict the properties of elements undiscovered at that time. Grouping the elements. Each box in the periodic table is like a mini biography of an element. Each box tells scientists an element's name, symbol, atomic number, and atomic weight. Scientists can also learn about an element by seeing where it is located on the chart. In the periodic table, the rows left to right show the periods. The mass of atoms increases from left to right along a row, and the elements change from metals to nonmetals. The columns, top to bottom, are known as groups. The mass of atoms increases from top to bottom, and all elements in the same group have similar properties. Elements on the far right of the table, for example, are part of the family of noble gases. These are gases that never combine with other elements. Noble gases include helium, neon, and argon. The periodic table today. After 1869, the gaps in Mendeleev's table were filled in as scientists discovered more elements. Today, 112 elements appear on the periodic table. Of these, only 92 are elements that are found naturally on Earth. The others are known as artificial elements. They are only produced in a laboratory. Since 1900, many other ways to arrange elements have been designed. Many of them are improvements on Mendeleev's periodic table. One of the most recent arrangements is a three-dimensional chart that displays the elements in horizontal rows and vertical columns. The chart also adds height to the boxes of the elements. The third dimension adds information about the size of the atom. Arrangements of elements have been evolving for more than 200 years. Each has helped scientists better understand the nature of elements. Each new arrangement has improved on an earlier arrangement. Who knows? Perhaps someday you or another scientist will design another arrangement that will lead to more knowledge about the elements. Super scientist James Andrew Harris. In 1969, James Andrew Harris helped a team of Americans discover element 104. The following year, Harris also helped discover element 105. Harris, a Texas native, was working at the Lawrence Berkeley Laboratory in California when he helped make the discoveries. Element 104, also known as Rutherfordium, and element 105, now called dubnium, are among the heaviest of all elements. They are not found outside a laboratory, however, and there is no known use for either element.